Hi everyone. So I have one of the slots after such a privileged and distinguished teacher, Yun Yao. And after lunch we're always a little tired, right? We have a little bit of coffee, but it really hasn't sunk in yet, right? So I want you to do some stretching, and just go with me here. Yeah. Okay, that helps. All right, because I need you to ask questions, right? Because this is not fun if you go to a keynote and they're boring and they're just lecturing, right? And I also put the slides up so that you can get them on your own. So if you decide that you actually want to see the slides, don't take pictures of them. Just get the document. This will be at the end of the presentation too. So you don't have to make your judgment call now. You can try it on and buy it later. How's that? Does that work okay? So I gave you a talk title because I like to tell stories. I mean, you saw that yesterday if you were here. Okay, so how many people have heard of the boy who harnessed the wind? Okay, yeah. I only learned about this recently, but I think it's a really good analogy for how we are thinking about LLM prompting. And if you don't understand the connection, don't worry. That's the whole point of having an analogy, right? Because it's more fun that way. Okay, so this gentleman here, he is named William Kamkwamba, and he was a boy in Malawi, and he had a problem that his village, as you can see here, was impoverished. The crops weren't growing, he had no water. Okay, so how was he going to solve this problem? All right. And if you know the subtitle of the talk, getting harnessing the wind, the idea was that he could harness the wind to build a windmill. And a windmill gives two byproducts, right? It gives power and it can irrigate because you can draw up water from the well, right? So that's what he did. And it's an analogous thing that I think is important to us to think about how we deal with this in LLM prompting because we have the same type of problems, right? We have to make sense of all the literature in prompting, and it's not so easy to figure out what's the right solution to get to a good, satisfying outcome where we can prompt LLM as well. Okay. So with that, I'm going to talk a little bit about making sense of prompting as the first part of this talk. Okay, so on the right side of this, there's three gentlemen there. My student Long, who's in the front, and then his two interns, also from Vietnam, Duy and Hai. And what they did is they said, okay, when we look at all the different pieces of information out there, just like William, when he was trying to construct this windmill, he had to make sense of all of the different technologies and science theories, okay? How could he piece together a solution, right? So if you read out there in the scientific papers, as well as on blog posts, there are so many different ways talking about what's the right way to build an LLM prompt, right? So they went ahead and looked through about 150 different papers. There's guides from Anthropic. There's this other very famous paper from Brown University on how to look at prompt-based models, really understand the meaning of their prompts, right? Okay, and what they did is they categorized the properties and the tasks and the models that they examined, okay? And so they built this huge chart that's in the table that's going to be presented 2 days from now at ACM. So I'll be giving the poster because unfortunately they aren't able to attend, about the meta-analysis of prompting. And this is a very, very busy paper. So I'm gonna step you through it a little bit, okay? So the first thing is at the top, right? On the x-axis, you have categories of tasks. So we put it up into 6 categories. So we have things like real-world chat, right? But also reasoning and QA, as well as generation tasks, right? When you're trying to generate a discourse or natural language understanding or other things of that sort. And then on the y-axis, we have properties, right? So there are about 21 properties here. They're organized into groups, and it actually makes more sense to go through all of the groups. Okay, so I'm going to do that for you. Okay, so the first property set is about communication. So all the things that we learn about Gricean maxims, like be relevant, don't tell falsehoods, okay, even though, sometimes we hallucinate, or the model does that for us, or be polite, right? All of these things follow Gricean accent of conversation. There's also cognition. So cognition has to deal with being able to do a good job of not talking about irrelevant information, being able to structure the information into parts. That's the germane load, to be able to task the instruction appropriately to what's going on. Also for instruction, okay? So there's a framework called 9 Events of Instruction, Gagne's 9 Events of Instruction. So here he looks at the different top elements of having a conversation to give instruction to another person, right? So we can look at this. So for some of the things that you see here are being very clear about what's the objective, how are you going to evaluate it? Oftentimes we give demonstrations to say, oh, this is what I want you to do, either in the real world or in text, or, to give it a reward structure, right? So this is a lot of what our machine learning brethren also do. Okay, structure coming from logic. So being able to make sure that when you give instructions that you have multiple instructions that they make sense consistently over multiple instructions. So you're not leaving people hanging. When you come into the middle of a conversation and people are giving instructions, maybe it doesn't make a lot of sense. So making sure that context is flowing. Okay. Hallucination, making sure that you explicitly acknowledge incorrect generation, and then being responsible, making sure you do the right thing. Okay, so all these elements have been discussed over this entire matrix that you see here. Okay, so they categorize all the 150 elements. And you'll see a couple different things. One is the fact that there are some parts that are darker than others that corresponds to the number that you can see here. So this is 9. That means there were 9 papers that they categorized out of these 150 papers and blog posts that talk about that. And all the icons here, they're icons of models that were used during that set of instructions. Okay, so the first thing you'll notice that the results are not evenly distributed. This should not come to anybody's surprise, right? I mean, it's natural language we're talking about. People study what they want. So many studies, in fact, if you look at the third column, they concentrate on reasoning, question answering tasks, right? And many people, of course, they feel like they need to compare against the state of the art. So they compare against closed source models like OpenAI. I'm sure a lot of us debate whether that's the right thing to do because we also want to make sure that we make progress on open models, right? Okay. But there's also the case that from this matrix, we can see universal and task-specific properties. So again, if you look at across, right, you can see the second group over here has quite a lot of cases of elements that have been investigated for the reasoning part, right? And same conversation up for the first 2 parts over here, right? So from real world chat to generation, there's a number of studies that look at these evaluation suites, okay? So that's the case of universal tasks, but if you look in the lower right-hand corner here, right, there's also the case of quite a number of studies that have looked at the reliability and safety issues, right? Hallucination as part of this as well. Okay, so that's one part. That's when, our scientific brethren or our industries have told us what we should do in prompting, right? But we can also study actual prompts, right? So we can go and look at tested prompts online that have been published, those how-to guides that say, what are the right ways to, what are the good prompts, what do they actually look like, okay? So we had the students actually go and do this. They went and found a number of these collections of good prompts. Like here, you can see the top, the leftmost one says ChatGPT prompts collection. Okay, maybe some of you have seen these as well. Okay, and so we collected some of these prompts and we got human annotators to rank them on a free-form scale of 1 to 10, see whether they illustrate some of the concepts that you saw on the previous case. So we're, again, trying to triangulate the properties of whether those things that we've said in literature and whether the actual instantiations of those prompts tally or not. Okay? So here's another gigantic paper output. Okay, so again, a very large, matrix of results. So I'll just try to again step you through that. So first of all, there are a couple of cases where there's low correlations. So there's not a lot of agreement here because the annotator said, well, these properties are tested, but they're not strongly there. Okay, so if you rank it like 2 or 3, say, yeah, this property is here, but not very strongly, then we want to throw them out, okay? And so from this matrix, you can also find that there are certain things that we can pull out that seem to make sense, okay? There's a natural correlation between communication, which was the first property that I showed you right before, with logic. So that makes sort of sense. If you think about it, if you want to be precise, make sure the output exactly fits the type of instruction that your output, then you'll have more token efficiency, right? You won't be giving a lot of redundant answers or giving too much or too little, okay? So there's a good correlation between the exhibition of token efficiency, quantity, manner, and interaction with the structural and consistent logic categories, okay? And the second output of this is about hallucination awareness. Again, previously on the other matrix that I showed you, we saw that hallucination awareness and responsibility, bias, and safety, these things go hand in hand. In fact, we do see this also attested when we go to prompts that people have said are actually good prompts. Okay, so these things are being triangulated. We see confirmation both in what people tell you to do and what people actually do. Okay, so yeah, I forgot to mention that over here the red parts are a strong correlation and the blue parts down there are a weak correlation. Sorry about that. Okay, so they're a little bit separate from the scores inside, right? Because the ones that are cross-hashed out, these are the ones where things were correlated, but then the human judges didn't think that they were very strong. Okay, so we have to do the human judgment as well. Okay, so that was the first part of the paper. That was the large part of it. But the thing is, everyone wants to know, can you optimize for prompting? And I think you already know the punchline, right? I mean, we're all NLP people here. And so the short answer is definitely yes. Okay, I'm not going to tell you about it because this is a teaser and I want you to come to my presentation at ACL. Okay, so you can read the paper, you can ask me questions or come find me on Monday at ACL and talk to me about it. I'll be happy to answer your questions, okay? The little bit of a teaser is that you can do reinforcement learning on this matrix of different values and try to optimize and get better at prompting. Okay? So that's great. That's exactly what William did, okay? He went out there and he looked in his library and found a textbook about science, and he says, oh, I can use all of these physical properties of nature, what people have studied, and I can construct a windmill, right? So he found a textbook in Science, he digested that information, and he said, I'm going to build a windmill. This is going to show me how to save my village, right? So this is our textbook, right? This is telling us all the different ways that things are put together, right? And so when William comes and looks at the same type of thing, he's like, okay, I actually have to try to build a windmill. How do I do this, right? I have to give a long form generation of steps to build a windmill, okay? And so my student also looked at this problem and said, maybe what we want to do is study one part of that, which is about long form generation, okay? Like when we're not just producing short answers, a little bit like what Yunyao talked about earlier, short prompts and then have a conversation, give small amounts of information. But if I'm really trying to get a recipe for how to build a windmill, there are multiple steps and I have to generate it all, okay? So how do we do long form generation? So in terms of this matrix then, it is something more specific, okay? About being able to construct this part of the graph, okay? So this part here in red, right? So what happens in long form generation is that we actually have a really hard time dealing with in-context learning, right? In-context learning is when at test time we give information about demonstrations and we ask the system to follow my lead, right? And give a generation that we want, right? And so one of the things we attest in this paper is we give as quasi-mathematical proof that this problem really does exist. Okay, when you have long-form generation, even if you do demonstrations, it's not sufficient enough because there's out of distributional properties. There's just too little data to be able to follow the instructions well enough to give out of to solve this problem of out of distribution. Okay, how can we solve that problem? Well, one way we can do it is to think about giving clearer objectives. So even though we are already telling the system what to do, maybe we need to expound upon it some more to give better metrics for a system to generate results for that. Okay, so I'm going to talk to you about this other ACL paper coming on Monday as well. It's called Long Guide. So here's the architecture, and again, just like all the other diagrams I'm going to show you, I'm going to step through what all of the system parts mean. Okay, first and foremost, we're going to do steps 1 and 2, which are to take this tiny training data that we have for like-minded tasks that are related, and we're going to look at all of the different ways that people decide what type of metrics to use and judge long-form generation tasks. So we compiled about 27 different metrics or properties that are commonly used to evaluate long-form generation. Okay? And then what we're going to do in part 2 here is then ask the system, okay, as an LLM, maybe you can help look at this task, think about which of these 27 metrics are relevant for this task, right? Because we're going to add them in and say, for this particular long-form generation task, you should also worry about these other guidelines, okay? Even though they weren't initially explicit, now we're making it explicit to help guide the system along. It's like, when a professor gives you an assignment, you're not sure how to answer it, you go to the TA and the TA says, well, we have an evaluation metric or rubric, here's what I'll be grading you on, okay? And then trying to expound that a little bit more. Okay, so for the metric guidelines, that's the next part, right? So here we say, okay, when we decide which ones to operate, right, we might say, okay, we need to have the summary to be very concise, it has to be highly relevant, it has to have a good amount of relevance and be informative, right? So that's this last part where we then take those guidelines and then use the LLM to generate the actual instructions that are relevant to that task. Okay, then we embed it in the generation prompt. Okay, so that's the first half. The second half has to do with the right-hand side of the slide. Okay, and that is on output constraint guidelines and then the hybrid selection of everything else. Okay, so for that, what we do is we look at all of the data for related tasks of this sort, and we ask ourselves, what does the output actually look like? So this is a little bit like the corollary to the second part of the other paper, right? Where we're going to look at actual prompts, right? So here we're looking at the actual output of other generation tasks. We're asking ourselves, how many characters does it have? What type of style is it written in, etc. We try to back infer what those properties are, okay? So you can see on the right-hand side of the slide here, right? The summary must have between, a certain number of sentences and an average of how many words. Again, there's no LLM that's going to obey this explicitly, but again, these are guides, right? This is just helping you get a sense for what a good answer is. Just like all of us who are professors, you get students that say, hey, exactly how are you going to grade this? I need to know whether you're going to grade it this way. Do you expect a long answer or a short answer? Well, if you tell us, then I can follow better, right? So that's the idea. We expound that to the LLM and tell you. Okay? And the last part of this is the bottom part 5, which is that we have too many different constraints that we want to take. And if you give too many instructions, people get overloaded. And it's the same for an LLM, right? So we have to distill which ones of these metric guidelines, which were on the bottom left, and the output constraint guidelines on the top right, are the right ones to give to the LLM to concentrate on. Okay? So we make that selection through another neural network. Okay? And so you can see at the end, it selected a couple of different things here. It says, okay, we want to be brief. That's the overriding principle for this particular task. And the summary has to have between certain number of words. Okay? So the takeaway from this other paper is that, we get robust improvements, okay, across models and across long-form generation tasks, okay? The paper is much more explicit about all of these things. There's a very long appendix. And I'll be happy to talk with you all more about it if you want to take a look at this. You might be asking, what does an ablation study look like? Okay, so funnily enough, giving very precise guidelines about how long, how short, what type of words to use, what types of thing avoids, actually helps a lot. And maybe it makes sense because oftentimes we are creating the system on the basis of other things related to that. If you think about rouge or blue, right? All of these metrics are looking at n-gram statistics, right? So it means that our evaluation metrics are mirroring the types of instructions that we need to get good on this. It's a little bit like reward hacking, right? We want to do that, okay? But again, the metric guidelines, the MG, the third bullet point there, influences language choice a lot, right? If you tell the system to use a certain number of words, it won't change the words that it's using. But if you give it guidelines about what overall you should be doing, it does emphasize the language choice, okay? So it works even better when given demonstrations. So you have a new task and you're distilling these guidelines from multiple tasks that are related. If you also additionally add in demonstrations, that gets better as well. All right, so we've gotten to the point where we have a way of generating an instruction, long form instruction for creating a windmill. Now we have to source the parts for the windmill, right? So William Kamkwamba, he also went to a local junkyard to source materials for his windmill. He actually had to convince his family members who thought he was absolutely off his rocker to disassemble their working bicycle, right, which was their only asset to create this windmill. Okay, he convinced them, but they were absolutely sure he was crazy anyways. But he did successfully think about how to do it, right? And we all know that when you're engineering an actual prompt or engineering a windmill, you have a choice of materials to use, right? So one of the problems here is trying to figure out what materials, what output format and a prompt, etc., might be the right one to use. So it's a, mostly non-scientific. It's trial and error that we do for the most part, right? And so my student also looked at this. He said, let's think about output formats. Like when I ask the system to choose an answer or to create a list, there's so many ways that I can do it. What's the right way to do it in such a way that I get the best results? Okay, so LLMs do produce different answers to the same question when they are asked to answer in different output formats, okay? So if you look at the thing on the right, it says answer the following questions step by step. Your answer is the character identifier A, B, C, or D, okay? How many positive integers are factors of 120 and also factors of 40? And then you give an answer, any one of these, right? And the correct answer is B, 8. And you can choose which format you want to tell the LLM to create the result. You could say, oh, you should bold the final answer. Maybe you should italicize the answer. Or maybe you should fill in the blank, like the answer is square bracket X, okay? And then the LLM is going to try to follow these instructions, right? And you would guess probably that it makes a difference and you'd be right, right? So if you look at the bottom part, okay? The first part says 1, find the prime, blah, blah, blah. Final answer is 8, B, right? So the instructions were just bold the final answer, but it also bolded the text value as well. It just wanted to say, B, okay? So it got the answer right, but the format for the answer was wrong, okay? The second one is more egregious, right? Because it chose the wrong answer, but followed the formatting instructions. I mean, that's no good, right? We want the answer more than the format, right? And the third one is best, right? To solve this problem, you want square bracket B, that's the answer, and we're happy there, okay? Okay, so actually I think this should be wrong. I think my student put it in the wrong way on the slide. Okay, but in any case, one of the big problems is we all know that format bias exists, but disentangling is not so easy because sometimes we get it right and we get it wrong, but we have to make sure that the output format and the correctness are separated values, they're entangled, right? So one of the things that we need to study is how to do that. Okay, so what my student did here is look at formats, 15 different formats that are roughly grouped into 4 cases. So I'm just going to go over just the first one here, multiple choice questions. So in fact, what we do is we give the LLM a task, and we give it a selection of answers that it needs to pick among, right? And we can do that in different ways. We can give it, just like I showed you on the last slide, say just pick the letter A, B, or C, or give me the text value, which is 8, 16, or 32, okay, or some combinations of that. So there are, I think, about 6 or 7 different ways that you can phrase the multi-choice question. Okay. Another way is to extract or generate a text span, right? And so when we do question answering, a lot of us who have worked with, let's say, the question answering data sets like the Stanford Squad, right? You have to extract the span and then put that as your answer. So to do that, you can also use a wrapping format. You can say, please enclose your answer in a set of tags, right? And again, not surprisingly, how you set the wrapping influences the results and the correctness. That's scary, right? Okay. You can also create a list. You can ask the system to create a list for you. So you can do it more like in a coding style, like a Python list, or you can say using delimiters or a bulleted list or new lines, okay? As well as create a map. So if you want to get attribute values like a dictionary, a Python dictionary, or YAML, yet another markup format, okay, that you can also do. So my student looked at all of these through his sub-team. Okay, so again, I'm only going to talk about the first part, which is about the multi-choice question format, okay? And actually, we vindicate all of the discussions that format bias does exist, okay? So here again, if you look at the text box on the right, you have the pink letters, these are the characters, and then the right-hand side is the textual value of the multiple choice question, right? So if you look all the way on the left in the white part of the chart, right, you can see there are very, very different values for how well a system is able to create the right answer depending on the output format. So Gamma, Minstrel, Llama seem quite inaccurate based on what type of formatting you ask for the answer. And this is across multiple data sets, across many runs, okay, that we've attested these values. The best, of course, seems to be ChatGPT here, where it's getting an F measure of at least 42 on these parts. But you can also see that using just the character, just saying, can you give me the answer A, B, C, or D? That seems to help a lot rather than asking for the textual value as well. Okay, and this is also instantiated when you talk about the output, the tasks that we're asked to do, right? So when we're asking for the task, you could be doing MMLU, a multimodal understanding data set, or another question answering data set, the BBH. Okay, and you can see there are again wide variations in performance. Okay, so in many cases we want to optimize for both performance as well as accuracy and format instruction. So it's very similar to the same problems that William was facing when he wants to generate electricity, but he also wants to irrigate his fields, right? So the question is, can you do both with one thing, right? And the answer, the punchline is yes, but still, when you look at all of these parts, you do see quite a lot of variation. Again, this is just for the multiple choice questions here. So you can see that with different models, doing something with, let's say, parentheses or brackets has a lot of variation, which you can see over here. right? You can see some of them are very far down, some of them are pretty high up, but italicizing seems to work pretty well. It's pretty consistent across models, right? Same for different types of ways of doing special characters, quoting, doing placeholders for fill in the blanks. Okay, so these are another set of tasks. Okay, so this is a task-based evaluation on the right, and this is a model-based evaluation on the left. Okay, so format bias does exist. In certain cases, when we have good solid answers, we can disentangle what's right from the format bias and instantiate these problems. The question is, can you mitigate some of these problems? And of course, the answer is yes, okay? So take a look at this chart again, higher is better, right? So you can see the stars at the top, that's the fine-tuned baseline. Not baseline, that's the fine-tune after we've made it aware of the format bias, right? But there are also different things here, I'm sorry, missed on this, which is that if you give it a certain number of demonstrations, actually, you can see the performance doesn't get improved a whole lot. Zero shot seems to be pretty okay here. But repeating the instruction multiple times is actually very helpful. So if you know a little bit about prompting, they'll tell you, give instructions at the top before you define the demonstrations or the data that you're giving access, but also repeat it at the bottom, right? Because that will help the language model focus on what you actually want it to do, okay? So doing that helps quite a bit. It helps more, surprisingly, than demonstrations do. Okay, so the takeaways from this last paper that I'm presenting to you today is that systematic bias does exist in output formats that we need to pay attention to when we're designing windmills or when we're designing prompts, okay? And the good news is that we can mitigate all of these problems by being aware of them and engineering our prompts accordingly, right? Demonstration helps, but fine-tuning also helps, and repeating instructions is worth doing. Okay, with that, I'm coming to the end of my talk. I hope it was an interesting journey for you. So we've come to the point where William was able to actually construct his windmill. And this is a picture of William, and after he's constructed like 3 windmills and bringing electricity and water to his village. And with that, I want to impress upon you that prompting is not a solved problem. It still deserves our attention as researchers, as well as all the other ethical and other aspects that we've been talking about over the last day or two, okay? We've mostly studied prompting from a single element perspective, but there's lots of different things you can correlate among multiple models, factors, and tasks, okay? And the important thing here is that even though, we're mostly in academia, a lot of this wisdom gets digested into models very quickly, and so we can see closed source models catching up, right? It means that even though we are creating these prompts and telling people how to construct their prompts, those things get reinforced into models very quickly. So there is improvement of these models quite fast, okay? What it means is that prompting is going to get even easier for people, and then as academics, we can do what we love best, which is concentrate on the residuals, right? All the things that haven't been done. Wait, this still isn't solved, right? And then we can write grant proposals, get them rejected, resubmit them, all this type of other stuff, and do it all over again. Okay, so I went through 3 works out of my students' 6 works so far on prompting. So these are all the ones that are here that I've talked about really briefly. To try to cover them all in one sitting would be difficult. So he's also done work on personas, how to create language models that align with human opinions, and also multiple prompting. And in other words, giving a role for each model to emulate an expert and have this expert consortium come up with an answer. And also, not surprisingly, you can also do this in a contrastive or adversarial manner. So doing that in context learning is also something that's possible. Okay, I'm going to end with a couple plugs here. I'm running a retrieval augmented course at NUS, where I come from in Singapore. I know this is not the right time zone to advertise this, but just in case you happen to be awake at GMT +8, okay, which I think most of us are, right? This is it's our evening time, it'll be your afternoon time or morning time. Then you can consider joining this course. So this is a public course because I'm not doing the lecturing. What I'm going to do is ask the students to put together the lectures. We have source materials, and it helps you, especially those of you as PhD students, you want to become lecturers, stand on the front of the stage and have butterflies in your stomach, then this is a good chance for you to do that. Okay, and more locally, there is the ACL ethics tutorial. I happen to be one of the co-chairs for the ACL ethics committee. We are having our tutorial tomorrow in Vienna, right, where it's, I heard, dumping rain at the moment, but hopefully it won't be that nice. We can encourage you to stay indoors and come to our ethics tutorial. So please join all of these fine confederates of mine and come to our tutorial tomorrow afternoon, right after lunch, same slot. You'll be similarly tired, but we promise you'll have an excellent time. Okay? So that's it for my talk. I'd like to thank my student Shen Long, or he's called Long, you know, it means dragon in both Chinese and Vietnamese, but he has a whole host of collaborators. He's like our, even though he's a senior PhD, he's more acting like an assistant prof at this point, and gathering his own team of students for this. And this is joint work between my lab, which is the Wing Lab at NUS, as well as our confederates over at A STAR, which is a little bit like DARPA or NSF in the US, and Nanyang Technological University. And in case you want the slides, there it is again, the QR code for that. And with that, I'm done with my talk, and I'm open for your questions.